according to the chemical composition. So the composition, it is in the 250 until 300 degrees C fractions. So we can see here, for the class of crude oil, for the paraffinic, it has paraffinic, naphthenic, paraffinic, naphthenic, aromatic, and aromatic. So it follows whatever compounds that they have here, right? Paraffins, naphthenes, aromatics as the examples. So this is the percentage of paraffin here, the one that we have, the one that they have in the compositions, and the characteristic of paraffin. I mean to say that for the paraffinic class, it has good paraffin wax and the quality lube and high grade kerosene. For the paraffinic and naphthenic, it has good paraffin wax, medium quality gasoline, and medium grade kerosene. For naphthenic, it has high quality gasoline, pure lubes, and kerosene. And paraffinic, naphthenic, aromatic, all products obtained but at lower yield. And for the aromatic, it has high quality gasoline and asphalt and high level of sulfur and nitrogen. Okay, for this classification, we will discuss further for the petroleum and natural gas products and the usage of it, the usage of specific products. Okay, this is the further classification according to the API gravity. So of course, API gravity is the really important currency. Sorry, I shall say very important unit for crude oil. So basically, that is the most important unit in crude oil uh, trade. All right. So according to the API gravity, so this is the list, the type of the fractions according to the gravity. So it has different fraction according to atmospheric pressure and vacuum pressure. So so we can see here for the paraffin and the type of fraction for different pressure, atmospheric and vacuum, 40 and 30, 40 and 21, 20.1 for the intermediate also, and naphthalene and naphthalene and naphthalene intermediate. Okay, so this is a different. This is for the classification for the crude oil if it is according to the API gravity. So I can see here that this is different, the name, different name that you can, for example, it is mentioned that paraffin, the crude oil in the group of paraffin intermediate. So basically you have to know what is the gravity and what is the fraction, but of course usually will be provided in the test or the final exam. Okay, for the crude oil assay, the crude varies between sources and oil field edges, as you can see from the previous slides before. And in order to indicate the quality, it is very crucial for the diverse feedstock plant, and it is based upon boiling points, and which is the expected product from the distillation process. And the amount of data required is the public report versus in-house analytical lab. And there are two programs, which is whole crude property measurement and full assay, and the sample must be representative to whatever composition that we extracted and we distilled. Okay, next up we have the property measurement or the crude inspection. So basically we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have eight. All right. The first one is the specific gravity, which is density of petroleum, normally using API unit called API gravity. This is the most utilized crude property measurement for making crude purchases, which is really important, and it is an industrial standard based on ASTM D287 1298 method. And the sulfur content is second most important property, influencing the price of the crude oil. So normally, as previously mentioned, also it is in the range of 0.1 and 5 percentage weight percentage in the dissolved hydrogen sulfide, and X-ray fluorescent technique ASTM D4294 or D5291 with above 5 percentage under the combustion method. For the zero above than 0.5 percentage, it requires more extensive processing for the content of the sulfur. Okay, next one is we have pour point. Pour point is the temperature normally 3 point above the point on the sample, no longer move when inverted. It is particularly important for crude transported via pipeline. So the transportation of the crude will be discussed and discovered by you during the SEL lecture. So make sure that you can get more info on that. Also, as rough indicator of paraffinic, low pp versus aromatic, which also influence the crude oil value. Okay, next one we have whole crude simulated distillation (TBP). The gas chromatography technique to determine the true boiling point curve and predicting crude yield according to ASTM D5307. This is a robust and quick technique within 1 hour to determine cumulative yield at different temperature. It is a valuable tool to assess whether a full assay may need to be updated or it can be done straight away. The next one is we have full assay, which is the true boiling point. The assay analysis of whole crude via atmospheric and vacuum distillation. Okay, previously we can see the composition according to atmospheric and vacuum. So it is done according to the assay, and it is a combination of both distillation produced through boiling point (TBP) curved, and anyway it is labor intensive and lengthy, which it took 3 to 5 days. The benefit is allows the distillation fraction to be tested, whereby the temperature cut scheme mimic refinery product classification with no standard formats. And for the plants, it tends to perform both physical and chemical testing best to meet their refining operations and the products. Okay, next one we have physical distillation. According to ASTM D2892. So basically, for the oil and gas industry, they have so many industrial standards that you have to follow. Exactly, and which determines the accurate TPP to the refinery fractionations. It is performed on a 15 theoretical plate fractionation column to obtain TBP with the reflux ratio of 5 to 1. It is slightly reduced pressure to prevent cracking from occurring, and the fraction cuts between 50 and 50 degree, and narrow fraction cuts are sent for physical and chemical analysis, which is up to 345 degrees C. Okay, next one we have physical distillation, which is the according to ASTM D5236, which is the bottom product atmospheric residue from atmospheric distillation and fed into vacuum fractionation to prevent crude cracking. It is generally produced a fraction for gas, oil, and lubricant range. Also, not industry standard for cutting scheme, which is 25 to 50 is common. So because for this one, the fraction cut between 30 to 50. So this one is 25 until 50. And the final cut is normally at 565 degrees C. So this one for final cut usually is going to be up to 345 degrees C. So there's a difference. And the true boiling point curve, the data is the data from physical distillation that runs used to create TBP curve. The curve is used to standardize the boiling point from atmospheric and vacuum distillation. It also determines distillation yield profiles in weight and volume percentage, and initial indication of crude's profitability. Okay, for the physical property test for hold on for crude oil, they have 8 physical property tests. The first one is API gravity properties test. So what is API gravity? API gravity determines the weight of crude oil per unit volume at 60 degree Fahrenheit, which is 15 degrees C. Mean to say that for the API lower than 10 degree, it indicates heavier asphaltic, and for the API higher than 50 degree, it indicates it to be lighter distillate. For example, ether condensate. The most crude occur in the range of 20 to 45 API, and generally higher API give lower sulfur, nitrogen, and carbon residue and viscosity. So this is a really important point. And next one is metal. Metal range between a few to several thousands ppm. It has low value of certain metal, for example, nickel and vanadium, which severely affect catalyst activity. And it is done by using AAS or ICP-CES method. Okay, for the physical property test, next one is merceptin sulfur. Sulfur containing organic chemical substance. However, it is undesirable species in crude oil, and sometimes toxic and smells like rotten cabbage. Alright, so you can basically imagine that, and normally attributed to sour crude because it is in regards to safety of the whole processing plant. Microcarbon residue. Carbon residue is proportional to asphalt content. Lower value give higher crude oil priced. Normally measured by convection carbon ASTM D189, distillation of cooked residue, and which indicates the heaviness of crude oil aromatic according to the percentage given. The next one we have Reid vapor pressure is a measurement of volatility of liquid hydrocarbon. It is generally used to predict gasoline performance. Also, the inspection for the whole crudes having a relatively high API, which is really important in the transport of the crude oil. Next one, we have salt content. To determine the corrosiveness of a crude oil, it is expressed in sodium chloride, kilogram per 1,000 barrel. To say that if it is that higher than this point, it needs to be desalting, means that the salt has to be removed. But catalytic process needs desalting even crude is below 4.5 kilogram. Okay, and economically desalted to make sure to be at this value, which is 0.5 pound per 1,000 barrel. Okay, next one is total acid number. It predicts the acidity of an oil distillate fraction. High acid causes rapid corrosion of fractionating columns, and with the typical total acid number value is 0.05 to 6.0 mg KOH per gram, and high total acid number crude is purchased cautiously for possible corrosion. And next one is water and sediment, which is a critical parameter as where the problems will occur during processing, and normally desalter equipment handles this problem. Okay, so that's all for the uh, refinery feedstock and the properties. Okay, we will continue further with the natural gas properties and the crude oil properties, products. Sorry. Okay, thank you.